Now, geometric proofs are a little more complicated, but not much. You have a diagram, and so we're going to need to figure out what exactly we need to do. Right now, we got that measure of angle AOC being this whole thing, all the way around here, this whole angle is 139. And then it tells us that this angle is x, and that's 2x plus 10. So we know that x plus 2x plus 10 is going to equal 139. We know that this piece, x, plus that piece, 2x plus 10, is going to equal the whole thing. Just the piece plus the piece equals the whole. Now we call that, as simple of an idea as that is, we give it this big fancy name. We call that the angle addition postulate. Postulate just meaning property or rule, just saying that take two angles, add them together, you get a big angle. Okay, we could abbreviate that AAP, but know what it stands for. Now once we get the equation set up, it really is just an algebra problem from there. It's just like the ones we just did. We're going to combine the like terms first. 1x and 2x make 3x. That's combining like terms. And then we're going to subtract 10 from both sides. You may write big and you may take up the whole thing. That's okay. You just will skip a blank here. You come down and say, alright, 3x, these cancel, are going to be 129. And you're basically taking up two blanks, so just right here, put property of equality. And then again, we're going to divide everything by 3. And we get 43. And again, it's the property of equality. Looking at the second one. Very similar looking, but we have something different that's given to us. Here it told us that the whole thing was 139. This says bisects. Bisect, literally meaning cut in two or cut in half, means that LM, which is right here, cuts right down the middle of this whole angle. It takes this angle and cuts it exactly in half. Well, if exactly in half, then that angle has to be the same as that angle. That 2x plus 40 has to equal 4x. And we know that. We know they have to equal. We know it's a fact. We've proven it because of that bisector. That bisector tells us that they're equal. We've proven that. Now we want to come in and subtract 2x from both sides. Now some people will put combining like terms here because we're kind of putting the x's together. But only time you combine like terms is when they're on the same side. Right now we're subtracting from one side of the equal sign and subtracting from the other. We're doing the same thing to each side of the equal sign. So that is the property of equality. Okay, these cancel. We're left with 40 is equal to 2x. We're already there. I wrote this first. And then, lastly, we're going to divide by 2. We get that x is 20. And that's property of equality. I kind of went outside of the blanks. That's okay. But I went from this step to this step because of property of equality, and then from there to there because of property of equality. And x is 20. Got the proof. Alright, next example. Moving on. AC. This now is a segment. We're not talking angles anymore. AC is 21. Now what some people will make the mistake of is say, oh, it's a straight line, so it's 180 degrees. Well, there's always, in any straight line, a 180 degree angle right here. That is, it's 180 degrees. But what we're talking about right now is the actual length of this segment. And AB is 2y inches or centimeters or whatever. It's that long. So we're not talking about the angle made, we're talking about the length. And AC, the whole thing is 21. So what we'll say now is that this piece plus that piece makes up the whole piece. That 2y plus 3y minus 9 is going to equal the whole thing. That a piece plus a piece is going to equal the whole thing. And we call that not the angle addition, but the segment addition postulate. Another big fancy name, but segment just meaning a part of a line. So it's really just piece plus a piece is the whole. Okay, and again, there we got algebra going on from here. 2y and 3y, that's going to be 5y. They're on the same side, so we're just combining like terms. Then we're going to add 9 to both sides. Did something to both sides, so that's property of equality. And then lastly, we're going to divide everything by 5, and that's property of equality. And now notice that each proof, each 6 that I did one step, gave the reason. One step, gave the reason. If you do all this first and then try to go back, it's going to make it a whole lot harder. My advice is to do it just like I did it. Now proofs are going to eventually get a lot more complicated. But right now they're relatively simple, and you're really only going to see a few properties show up again and again. One of those being an angle bisector. And that's just if you have an angle, a bisector is going to cut right down the middle, and it's going to make 1 and 2 exactly equal to each other. And so whatever algebra expression is here, you're just going to set them equal to one another. Whereas angle addition postulate, even though it looks very similar, and this may actually look like it's in the middle, but they may tell you that this is x and this is 20, and then they may come in and say this whole thing, ABC, measure of ABC, remember that m just means measure, they may say is 50. And so then you're just saying, okay, I know that this part of the angle, this is x, this is 20, so x plus 20 is equivalent to the whole thing, which they're saying is 50. So it's the part plus the part is the whole. Part plus part is whole. That's really both of these things. This is angle addition postulate. And then we'll skip down and look at segment addition postulate, which is very similar, but it's just for segments. Is that, again, they may say this is x, they may say that's 5, and then they may say that the whole thing, AC, is 12. And you're simply just going to say, okay, well, I know that this is x, this is 5, well, this plus that is 12. 12 is the whole segment, so x plus 5 is 12. And that segment addition postulate, we talked about that being your shin plus your thigh equaling your leg. Okay, and you're also going to see midpoint, which is kind of similar to a bisector for a line. So if you have something like this, they may tell you B is the midpoint. And if B is the midpoint, well, then you know this is exactly in the middle, so that has to equal that. So we'll maybe just say x is going to equal 5. And it's really that simple. You may also see, and I'll just come down here in this little space, but you may also see transversals pop up. And transversals is what we just went over on Monday. But that'd be alternate interior, same side interior, and corresponding. You could see vertical or linear pair. You could see some stuff like that. And I'll write that on there, vertical angles and linear pair. But really that's all we've learned thus far. And so that's really only 4, 5, 6, 7, 8, 9. Really only 9 things that could show up in any of these kind of problems. So the more and more that you practice them, you're going to get really, really good at them. Alright, so that's it for the proof lesson. Again, go through and put a star by anything you maybe have some extra questions about. One that maybe you need to see more examples like this or more examples like that. Whatever you feel like you need a little extra help on, make a note to yourself. Maybe just come in and put a star.